Hello, Mario! In this video, Mario's Survey Radiation Worksheet LS044 explained, I'm going to be working, showing or just giving an explanation of this worksheet that I've been working through with my students following a practical exercise. So let's go to the big screen and let's have a look and see what we can get set up here. So here we have one, two, that's the field note, that's there, and this here. So this is the first of all here on the left, and then we'll see from this diagram here, this is a field note associated with the exercise. So what happened was we set up each group set up on a peg or a mark randomly positioned here, and in this case it was SN for survey nail, although recently I've been using pegs in a slightly different location to this. And then at three different locations I located stick-on reflectors laterally on lampposts, but in this case here this was above a doorway. This was above a doorway, and this was on a tall fence post on the security fence. So what the students then did is they orientated 0 on one of the marks here and did a left and right face, and then continued round left and right face on the other two marks. This giving them a round of bearings, which they then reduced and orientated to get their unadjusted final bearings, final bearings here in this case, because there's no adjustment, it's just a set. For each mark they measured a distance from a horizontal distance, which was just mean, and then they also measured the vertical difference in height or recorded the vertical difference in height at each one, and then meaned those out. I then asked them to use an assumed RL of 100 at the peg that they were on in order to calculate the levels of each of the marks, which was just calculated quickly by taking the RL of the mark, adding on the height of the instrument, and then adding or subtracting the height difference. In this case they were all added to come up with a various heights there. So that was the practical side of it, recording the instruments in there. So then remains to then calculate, do some calculations, and what I asked to be done was to calculate the bearing and distance between the marks, the three marks like so, and then to also calculate an area contained within all four of the marks. I believe the area I got here was within all four of the marks, and the area done with a separate type of calculation, which I'll come to a little bit later on. So I'm going to now hopefully put up here the Trevor Sheet, which is how I've done the majority of the calculations for the bearings and distances. So here we are. We've set up, first of all, we're going to do what's called, with the Trevor Sheet, we're going to do what's called a radiation block. Now this is different from a Travis block. With a Travis block we cumulatively add these here, but with a radiation block it's just added to the one at the top here, to the first mark. So we're going from SN out to here. To determine the coordinate of that, we add on the northing and easting. Now just by way of a reminder, I've got my little calculator here. Here it is, the calculator. So well, this first one here, because it's 0, 0, it's always going to be all north, so 19.11. Obviously that's just going all north because that's 0, so that's very easily done. So I'm just going to look at the second one here and just to refresh memories on how we do that with the calculator. And you can see that we've got 92 degrees 1651. So first of all, the northing is always the cosine. So we just, for that one there, we go 92 degrees, 16 minutes, 51 seconds, like that, equals, this is one way of doing it, okay, and then I can go cosine answer, I can do it another way, close the brackets, equals, and then multiply that by the distance times 16.835, 16.835 equals, and we can see that there gives us 0.669. Okay, and I'm going to two decimal places here, so that would be 0.670 negative, as I've got it there, negative. Okay, and perhaps a little bit more efficiently we could do it this way here, and that would be to do for the easting, which is always the sine of the bearing. So sine, and it would be 92 degrees 16 minutes and 51 seconds, 51 seconds, close the brackets, times, and that would be 16.835, 16.835 equals, and that gives us 16.822 to three decimal places. We can, I think, go, there's possibly there's a way of setting the number of decimal places to 3. Shift mode, oh, that's probably it, 6, 3, and that'll give us everything to 3 decimal places, like so. Now, then the coordinate of that point is 7,000 plus minus 0.670, which gives us 699.33, and 3,000 plus 16.822. So once we've got, and then we can do the same with this one here, once we've got the coordinates of all of these things, there, we work out those coordinates here. So now it comes about that we want to calculate these bearings and distances here, from here to here. So if we want to calculate the bearing and distance from there to there, we first of all write down the coordinates. So R door, we write down the coordinates there, 7019.111 and 3000 in here and there, and that's from line 2 above. And then below that we write the right window, and we write in the coordinate of that from above. So just copy it into there. So now this all here is blank. So now it remains to calculate these out here. So what we do is we obviously need to get our little calculator back, and we'll put that over here. Now, so what we go is 699.330, is it? 699.330. So we go 699.33 minus 7019.111 equals, and that gives us minus 19.781. So that gives us the correct sign. So if we want to go from there to there, we've got to go minus 17.781. And similarly, this one here is going to give us 16.822 in there. So now that that gives us a we've got to calculate things out there, and tools, comment. All right, I'll just put us in here. So what we've got to do now is we want to possibly just work out how that goes. So we've got, perhaps I need to just put this bit bigger here, and then I can get my calculator back there like that, just to make this a bit bigger. So I've got 19.781, so I'll just do this one here. So what that means is I've got to draw a line from here, 19.781 down that way. So that's there, 19.781, and then I'm going to draw another line across here just to calculate from this one here, and that's sorry, this line here is going to be across here like this, okay, and that's going to be 16.822. So my actual resultant line that I'm going to calculate is going to be from here through to here. I'll just pick this up, put it up here like this. Okay, so let's maybe put some text in and around those. So this one here is going to be so that's our 19.781. 19.781. Let's put some lights on here. 19.781. Okay, so that's that distance there, and then this distance here is going to be in here is going to be 16.822. Okay, so this is coming down this way because it's, remember, that's negative. Oops, negative 19.781. So that's how we know that it goes down. And then this is 16.822 this way. So to calculate this here, we know that it's that squared plus that squared, take the square root of that. So here's our calculator. So let's all clear. 19.781 x squared equals plus 16.822 x squared equals, and then we take the square root of that, the square root of the answer, equals 25.967, and that gives us our number in there. So that's just using Pythagoras. The square root of that squared plus that squared will give us that. So now we've got to work on the angles, and what we find is that we're working with this angle, this little angle here and here. Okay, that's the angle, and if we want to go for that, the thing that we're going to look for there is it's going to be tan to the negative 1 of 16.822 over 19.781. So let's get our calculator up here, and that's going to give us this little angle in here. So so let's go shift tan to the negative 1. Okay, 16.822 divided by 19.781, close the bracket, equals, and that gives us this angle in here, 40 degrees. But what we want, the bearing is measured clockwise from north. So the angle that we want is this angle in here, clockwise from north. Clockwise from north. So we get our calculator back. So what that means is we've got this angle here. So we're going to equals, let's just go 180 minus the answer equals, and that'll give us our bearing. And we want that to be in degrees, minutes, and seconds. So we just click on there, and there it is, 139, 37, 18. Okay, round through there like that. And so that's can be done for each one of these here. You just get the relevant coordinates for the 2 points, write them in there, work out the backwards, the ordinates, and then you can put in the bearing. So now if we let's just get rid of all this here, tidy everything up again, like so. Just get it back to where it was. We can see that that gives us the Trevor Sheet, and yeah, with the little Trevor Sheet we can get all our bearings and distances all recorded there like so. And here's our sheet here, and so what we do is we write our answers on here like that, write that they're calced, and get them all through there. And so that's that bit done. Now the other thing we want to do is work out the area that's enclosed between the peg and the 4 marks. Now the way to do that is to split the shape that you get into 2 triangles. There's one triangle here, one triangle here, and the formula that you can use for that is a formula half BC sine A, which you can just sort of make out as written there, half BC sine A. So first of all, you must work out what these angles are. So that one there's 0, 92, 16, 51. So that's the angle in there, 92, 16, 51. So we can quite easily work out the sine of that, sine 92 degrees, 16 minutes, 51 seconds, close. And then we can multiply that by the other 2 sides, which is these sides here, 19.111, 19.111 times, and the other one 16.835, 16.835. So that's half BC sine A is effectively means the half the sine of the angle, and the times the 2 side arms of the angle, which you've got there. And so we can push in the equals, and that gives me 321. Oh, and we've got to take half that, of course, so that's times 0.5 equals 160.739 or 74 meters squared, which I've got there, and so we can work out the other answer there. So yeah, pretty much that's how it all rolls, that particular one. I'll see if I can get this. Oh, that's not what I wanted. This one here, that there, and that can drop back down into there. So here's our nice little Trevor sheet here. Works out there, and draw it up on the diagram. And so that's it pretty much all finished. So yeah, let's just see what we've got there. So yeah, what we've ended up with there is yeah, that's just worked through worksheet 44, is it? Yeah, I think it is worksheet 44. So that seems to have worked out reasonably well and quite straightforward. So just a little bit of an explanation. Yeah, if you've got any questions about that, you know, just send me a note below, or get in contact with me. You know where if you know me, you'll know how to do that. And yeah, we can go from there. So I hope that helps in sorting out that little one for you. So pretty soon I'm going to stop recording. So cheers. See you.